In this video, we're going to be looking at surface areas. So here we're going to be finding the surface areas of these 5 different figures of right prisms, a cylinder, a cone, a pyramid, and a sphere. And we'll start with the surface areas of right prisms. So here we need to define what lateral area is and what the surface area is. The lateral area is always the sum of the area of the lateral faces. Okay. So I'm just going to use an illustration of something like this. This right here is pretty much my container with paper clips in it. It's like a circular cylinder. The lateral faces is going to be this right here. The surface area is going to be the sum of the lateral surface areas and the area of the bases. So here, if this is the lateral surface area, then the top and the bottom represents the surface area, because I'm getting the sum of the area of the bases along with the lateral surface area. We'll start off with a cube. The surface area of any cube is going to be 6 times e squared. In this case, the e is the edges of this cube. Okay, and this is what it looks like as a net if you were to cut out the cube altogether to make it a 2-dimensional figure. It will look like this, 2 dimensions. So in this case here, let's say that the edge of this cube is 4 centimeters. And I want to find the surface area for that cube with the edge of 4 centimeters. So here the surface area is equal to 6 times e to the second. So in this case, I'm going to take 6 times. The edge is 4 centimeters, so that's 4 centimeters, and that's going to be squared. And it's going to be multiplied by 6. Well, 4 squared is 16 from the 4 times 4. So 16 times 6, that's going to be 96. And it will be 96 square centimeters for the surface area of the cube with the edge of 4 centimeters. Okay, and then you have a right pentagonal prism. And this is just an example because you can use a right triangular prism, you can use a right square prism, does not matter. Here in a right pentagonal prism, for example, the surface area is always going to be the perimeter times the height. P is your perimeter, H is your height of that prism. So it's P times H plus 2 times the base. And the B is going to be the area of that base. Okay? So whatever the base is, because this like here, your top and your bottom, those are your bases. These are your lateral faces of that pentagonal prism, of the right pentagonal prism. So here, you'll take the perimeter, multiplied by the height, or actually the perimeter of the base. You'll multiply it by the height, and then you'll add to it the area of these 2 bases. Let's look at an example of that. Let's say we have this right triangular prism, and we want to find the surface area of that prism. Here we're given the dimensions in centimeters. Notice that the base is a triangle. So here we have to use the formula for finding the area of any triangle. So the area of the triangle, of course, is 1/2 the base times the height. And I'm going to write that off to the side, because that's the area. That's the formula for finding the area of a triangle. In this case, the base and the height of that triangle are perpendicular. So we have to use 3 and 4. The base is 3, the height is 4. So here you have 1/2 of 3 times 4. Well, if you do 3 times 4, that's going to be 12. 1/2 of 12 will be 6. So this base is 6 centimeters, 6 square centimeters. The perimeter is going to be the sum of the lengths of the sides of that triangle. So you add the 3, the 5, and the 4 together, you're going to get 12 centimeters. That's the perimeter of that triangle. So now the surface area is just 2 times the base plus the perimeter times the height. Well, 2 times the base was 6 square centimeters, so that'll be 2 times 6 plus your perimeter, which was 12, so that's 12 times the height is given to us in this problem. That's 10. So 2 times 6, that's 12, plus the 12 times 10, that's 120. 120 plus 12 will give you 132 square centimeters. So the surface area of this right triangular prism is 132 square centimeters. Okay. Now it's all about the matter of just knowing that the formulas for finding the area of a triangle. It could be a square. So you have to use the formula for the area of a square. Next is the surface area of a cylinder. Okay. Let's say we had right regular prisms, like this one. If we increase the number of lateral faces, it'll be this. And if we continue to increase the number of lateral faces, it'll progress to this. Continue to increase the number of lateral faces, it will get closer and closer to this, which will be a right circular cylinder. And we do have a formula for finding the surface area of a right circular cylinder. And that's this formula. 2 times pi times the radius squared, and that's what r is, the radius, and that's squared, plus 2 times pi times r times h, which is the height. The r is the radius of the circle, the height, h is your height. So if you cut this out into a net that looks like this, your 2 bases are your circles, so that's where you have 2 times pi r squared, because the area of a single circle will be pi r squared. But you have 2 circles, so it'll be 2 pi times the square of the radius. Plus, this length is 2 pi r, and then you have your height. 2 pi r times h. Now let's say, for example, I have a right circular cylinder looking like this, and the radius is 6 centimeters. I'm just going to write down the dimensions here. The radius is 6 centimeters. The height is 12 centimeters. And here I want to, and this is going to be for a right circular cylinder here, with a radius of 6 and a height of 12. And I want to find the surface area using this formula. Okay, this is going to be quite simple. I'll just rewrite the formula. Now I'm going to use SA as the surface area. 2 pi times the radius squared plus 2 pi times r times h. And here I'm going to leave my answers in terms of pi. So in this case here, r is the radius, that's 6. So I'm going to have 2 pi times r, which is 6 centimeters, and that's squared, plus 2 pi times r, again that's 6 centimeters, times the height, that's 12 centimeters. Okay. Now we're going to simplify this a bit. 6 squared is 36. So I'm going to have 2 pi times 36 square centimeters plus 2 pi. And if I multiply 6 times 12, that's 72. So that's 72 square centimeters. Now 2 pi times 36, that's 72 pi centimeters squared, plus 2 times 72, 2 pi times 72, that's 144 pi, and that's square centimeters. Now add 144 pi to 72 pi, you're going to get 216 pi. And this is in square centimeters. So the surface area of this particular right circular cylinder, if you were told that the radius was 6 centimeters and the height is 12 centimeters, that surface area will be 216 pi square centimeters. Okay. So in this case, that's how we find the surface area of any right circular cylinder using this formula. Okay. Next is the surface area of a pyramid. Okay, so here we have a right square pyramid. If you were to cut out the pyramid into a two-dimensional figure, it will look like this. Because you can see that the base is your square pyramid, is your square. Then these lateral faces are triangles. And they're isosceles triangles, by the way. Okay, so for a right regular pyramid, the surface area is going to be n, which is the number of faces, times 1/2 the base times L, which is your slant height. Okay, so here this should be L here. That's your slant height. And the B is going to be the area of the base. Now, we can simplify this because N times B, that's basically the perimeter. So we can say that the surface area of the pyramid is 1/2 the perimeter times the slant height, and it's going to be added to the base. And the base can be a square or a triangle, because you have to use the appropriate formula for finding the base area. So in this particular situation, if we want to find the surface area of the pyramid, which is a right square pyramid, first of all, the base is a square with the length of the side is 4 centimeters. So the base will be 4 times 4, length times width, which is 16 square centimeters. And then the perimeter, well, actually, the perimeter of that base, that's 4 times 4, because each side has a length of 4. So 4 times 4, that's 16 centimeters. So here, we know the slant height is given to us as 5 centimeters. The slant height, by the way, is the height that's on the face of that pyramid. Not the vertical height, just the height is on the face of the pyramid. That's why it's called a slant height. So here we use this formula, 1/2 multiplied by the perimeter, multiplied by the slant height, plus the base. Well, we have 1/2 times the perimeter of that square is 16, multiplied by 5, which is your slant height, plus the base, which is 16. So if you take 1/2 of 16, that's 8. 8 times 5 is 40. 40 plus this 16 will give you the 56 square centimeters. So the surface area of this particular right square pyramid would be 56 square centimeters. Okay. All right, the next thing we'll look at is the surface area of the cone. Okay, if you take a right square pyramid like this, or a right regular pyramid, it doesn't have to be a square pyramid, but it can be a right regular pyramid, increase the number of sides of that base, you'll see as you continue to increase the number of sides for the base, it will be close to a cone, close to a circle. So instead of a right regular pyramid, you're going to have a right circular cone. Okay? Where a radius is given and a slant height is given. So the surface area is going to be this, pi r squared plus pi r times L. And in this case, R is the radius, and your L, by the way, is the slant height. Because this right here is L. That's the slant height. That's the height that's on the face of that cone. And if you were to cut out the cone in a two-dimensional fashion, it would look like this. There's your circle, and then these triangles represent the pieces of the cone. Okay, so an example of that would be this. Let's say we want to find the surface area of the cone. We got the radius of 3, and notice that your slant height is 5. This 4 represents the vertical height from the tip of the cone being perpendicular to the base. We don't use this length. We don't need that length. We're going to be using that later on when we're dealing with volume of a cone. But for now, when we're dealing with surface area, we want the slant height. That's the height that's on the face of the cone. So in this case here, we're using the surface area, which is equal to pi r squared plus pi times r times L, which is your slant height. So here we got the pi. The radius is 3. Here's the radius on the base of the cone. That's 3. And that's going to be squared. Plus pi again. Times r, again, that's 3. Times L, which is your slant height, that's 5. So if you simplify this, 3 squared, that's going to be 9. So that's going to be 9 pi. 3 times 5, that's 15. So you have 15 pi. 9 pi plus 15 pi will give you 24 pi. So the surface area will be 24 pi square centimeters. And then a final thing we'll look at is the surface area of a sphere. Okay, keep in mind the sphere is nothing but like a ball, and it does have a radius. It's in 3 dimensions. So the surface area will be 4 pi times the radius square. So in this particular situation, let's say for example the radius was 4. Okay, tell you what, let's say the radius is 9 feet. And I want the surface area of this with a radius of 9 feet. So the surface area is just simply 4 pi times the radius square. That's the formula. So in this case here, we got 4 pi times 9 feet, and that's squared. Okay, 9 feet squared is 81 square feet. And then 81 times 4 will give me 324. So I have 324 pi, and that's square feet. Okay, and I'm leaving the answer in terms of pi. So the surface area of this particular sphere with a radius of 9 feet will be 324 pi square feet. Okay, so that's how we use that formula to find the surface area of a sphere. Okay, and that will conclude this particular video on just surface area.